So right now what we have here is we have our parts we're going to use to assemble this setup. So over here we have the initial doorbell, we have the solenoid that's here. We're going to use mainly ESP8266 as I mentioned. We're going to make, we're going to use MOSFET, which stands for metal oxide field effect transistor, to switch the solenoid, and we're going to use a MOSFET driver, which is this TC4420 driver, to basically switch the MOSFET. This is a very simple part. So right now I'm just going to put this we're just going to find a way to fit everything onto this breadboard. It's all about prototyping. We just want to get a rough idea of what's going to go where and how we're going to fit everything together, more or less. Basically, will the circuit work or not? It is not a point to be very particular about design. We just want to make sure the circuit works. So a very neat, as mentioned in some other videos, which I think will be uploaded soon or have not been uploaded yet, we want to put our components across this break over here, because this, we know that the breadboard's rows are connected like this, and these edges are connected like down the columns. So we do want to have some separation in our breadboard, in our breadboarding, if we want to put an IC. So our IC always has to sit across these two regions. So for our TC4420, we need to first identify the little break in the small recess over here. If I can zoom it in, we can see there's this tiny little gap, a small little like notch that is built into this IC, and I don't think my camera wants to. Okay, you see a tiny little notch over here, and this notch is the indicator to tell you where the head is. So generally I like to orient the notch facing in one direction. So in this case I will follow the direction I put for my ESP8266 and just stick a notch right here. And for our MOSFET, we just gonna put it in facing us. For now, we might want to change it later on. So referring to the spec sheet, you know that the MOSFET is a IRFZ4N, and the pinout of this MOSFET will be gate drain source from, for instance, if I take another MOSFET I have here, this is the gate, this is the drain, this is the source, and more videos coming up on the MOSFETs, so stay tuned. We basically want to be able to, minimize the use of our wiring, so we try to put everything as close as possible. So in this case, I just put the MOSFET next to this, but make sure the pins don't coincide on the same line, because that would be quite disastrous. Now I'm just going to use these wires that we have here. These are 22 gauge single core wires, which I use very much for breadboarding. They are much better than jumper wires because they don't, jumper wires sometimes are a bit iffy, the resistance is quite high, the connection between the molex and the wires itself are a real pain. So I'll usually try to avoid using them. I just use these wires over here. Maybe I'll do a video on how to actually make them. So first things first, we refer to the TC4420 data sheet. We see that the first two pins are going to be power. So I'm just going to connect these two over like this with a single jumper wire. Sorry, not jumper wire, this single flux wire, what to call it, this wire, and then I'll do the same for ground. And this is just to visually remind myself that these pins are connected, so I can kind of think of a way to use either of these pins if I do need them in the future. Next, we're going to go into our circuit, which basically will comprise a switch, which is the MOSFET, and the following, and of course the load, which is our solenoid over here. So these two terminals are the terminals for the solenoid. If we look at this, like the markings, this over here is a plus symbol for the battery. So I would assume that this should be the voltage, the voltage plus, which will be about 5 volts, which will be 5 volts in this case. So I'm just going to put this onto the plus line, because that's a universal marking for our positive rail, and I'm just going to take a long black wire and put it on our negative rail. So this is where we're going to connect our power supply. So once again, the power supply will be connected to the positive rail. So I'm just going to unscrew this a bit and slip this underneath, because we do want, we will need power for both our board as well as the power for both our board as well as this solenoid. So that's done. Now we look for, we know that we need to be able to also power, basically switch the solenoid. So well, we refer to the operating mechanism of N-channel MOSFET. We know that it switches on the low side, so we put the MOSFET after the load. It's like having a switch after the load, and that current and that the order of the pins, or the order of the prongs on the MOSFET is from current will flow from drain to source. That's just how the naming goes. Kind of counterintuitive, but that's how I remember it. So we know that on this MOSFET over here, we remember that this is gate, drain, source. So we know that after it we connect wire to the negative terminal of the solenoid, we have to go straight to the drain. And then maybe I'll use my wire stripper tool to make this thing more pronounced. So give me a moment while I just remove more of the wire, remove more of the casing over here and here. It's just one more. Alright, so put it here. And our source will go back to ground, so I can sort of, I'll use maybe I use this long black wire over here to connect this source. Oops. To ground, and then this ground will then be serviced by our power supply unit. Okay, so that's pretty much done. Now we want to be able to control our switch as well. So we're going to use the this WeMos. So we know that the pin for our PC 4420, the input pin is going to be the second one from the top over here. I'm just going to put that straight into maybe D2. Anyone would do. Okay, maybe not D0. D0 is a bit iffy. But yeah, no, not D0. That D0 is a bit iffy from my experience, and not into the TX and RX pins either. So D2 is a pretty safe one. And then we have to put our output to the gate. So output is either of these two over here. These two are the edges. Maybe I'll just, it's either these two on this edge, and we just put it straight to gate. And of course we need to remember to connect the power and ground of our TC4420 to the respective positions. So we're just going to put a small wire over here between the power and the rail that we've created. We do the same for ground as well. With maybe we don't need such a big wire, we can use a much smaller wire, like in this case. No, we do need a big wire because I've realized that from earlier experiments kind of burned out the holes that existed somewhere around here in the breadboard. So there we go. And after that, we just need to connect another set to our ground and our power of our WeMos board, because we're going to simulate powering this on off this our power supply. In this case, we're just going to use a lab and power supply, but I will also be testing this out on actually using the SMPS module that I've gotten, just to make sure that everything works so that we don't waste our time when we add it. So everything looks good here. I'm just going to go back very quickly, check our wiring. So these two is correct. The output, yeah, this either one would do. Gate, drain, source, drain to source. Everything is correct. Now we're just going to take our trusty lab bench power supply cables. Just going to connect them So our board like this is the negative, this is the positive. I'm just going to turn it on. We've done everything correctly. When we press our reset button, we should see that the little board lights up. So like this. This means that we've got it, everything is going to work, or at least everything should work correctly. I've already flashed the code into this WeMos, which yeah, I will upload it and maybe we'll do another code walkthrough of this project as well. It's a very simple code that just uses Blink as an example. Perhaps in future Blink tutorials I'll also discuss more in depth on how exactly to use Blink, but it's just a simple Blink sketch that can be easily reproduced on using some simple Blink libraries, so not too much. So right now I'm just going to take my mobile phone, if I can find it. Where did it go? Oh, I'm using to record the video, silly. Okay, so alright, maybe I'll just try this. Maybe you can try to use I'll try to use the Blink only works on that mobile application, so unfortunately I can't even check if this Blink has been connected. If this WeMos D1 has been connected to Blink. Well, we wouldn't know. So I'm just gonna wait a moment. Oh, and I've realized that I have connected. Oh, a silly mistake on my end. I realized I've connected these. This is the wrong. I connected this is the wrong side of the doorbell. That the relay actually is over here. So sorry, quick fix. Just spin this around. Connect it like this. Of course, be sure to turn off your power supply before you make any changes, just in case you actually short the components. So this is the right side. No wonder nothing was happening when I was pressing my physical button. I'm just going to turn it on again. And just give it some time to load. Leave. Alright, so it seems that the thing is booted up because the pin is now been put to low. It takes about 30 seconds because I'm using an OTA sketch, so there will be a 30-second delay between the reset and the main code actually being run. We have no idea when this will actually come online because unfortunately the phone I'm using to record it has the app, so we'll just have to wait. Hopefully it should come online soon. There we go. So we see that everything works pretty well. To see if, well, maybe I can now demonstrate how this thing actually works by flipping it over. So being very careful. You can bring this down. Oops. So we can see there's a little coil over here, and when we press the button, or now at least our physical button, we allow current to flow through this coil over here, and that will basically induce a magnetic field, and that causes these what do I call these little chimes, these metal plates to vibrate, and that creates the sound of the bell. So we'll just play with it for a bit to just double check everything's working. But this is a good sign. We've got it off to a great start. So when I press my physical button, which basically sends a command to the Blink server via a bridge, I'll go through this during the software run through of the project, but for now just assume that this is akin to setting the digital pin of the WeMos D1 high. You see that everything works as planned. Yep, everything looks good. We can also observe the current. This is can be seen from our lab and power supply. So when I press the button, see that the current increases and the current decreases as well. So far so good. So just gonna pause for a moment to prepare the SMPS, and we'll be back. Alright, so it's started raining. I hope you can hear me over the rain. Over here I have a tiny little SMPS module which I bought from AliExpress. Link will be in the description below. Basically it's a switch mode power supply that converts AC. Oh my, look at the lightning. It converts AC to DC and then uses a switch mode switch. I don't really see the inductor. Okay, the inductor is probably here. Then it uses a switch mode power supply principle to buck or boost the voltage. I think it should be buck. Yeah, because it's probably a very high voltage and then pushing it down to a lower voltage for us to use. So it's a 220 AC to 5 volt DC little board here. And I'm just going to turn off my power supply, lab bench power supply for safety reasons. I'm just going to look around. How am I going to fit this in? So maybe I can put it like this. Well, maybe, but as you can see here, we know that our circuit has to start from here. This has to be the positive terminal and this will be the negative terminal. So it wouldn't make sense to reduce the overall wiring of high current carrying wires, and knowing that this the only thing that will be drawing at about 1 amp will be this doorbell solenoid, because the WeMos D1 doesn't need that much current. In fact, it's only about 0.5 amps at most, probably less. So I'm not going to put this here like this. Probably be a good way to reduce the overall wiring and also just make it much more simpler. So we could put this here. I mean, no difference. This all depends on your application. Of course, I don't think you'll be able to find the exact same doorbell that I have. I'm just going to put it here for the sake of this example. So I'm going to put it here, and I think this should allow me to close it. So I'm just going to take out these wires over here and take the cover of our, oops, everything's falling down. I'm going to take my cover of my doorbell. Just going to check that it can close. I mean, quite silly if it doesn't. So the cover goes on like this. You can see it closes well. Everything lines up. Alright, just going to put it there. So now that we have secured a position for our power supply, let's actually let's actually solder this power supply to the mains, and let's actually check to see if this supply actually is going to work with our setup, because you never know. So alright, so now that we're done, let's actually make our stuff a permanent solution. So over here I have a perf board. This is a board with, a bit over, we see there's many copper holes, and basically we put our components in and we solder them, and once that happens, the components aren't going anywhere. So basically we're just going to think of the positioning of these parts in the right places. So as we remembered earlier, we can refer to our schematic for our TC4420. The first two pins over here are power. This one is going to be input. This is not going to be not connected. I've drawn a small little black line over here to show that it's not going to be connected. This is going to be ground. This is ground as well. These two are going to be output, and this is going to be power. So we just put we put attention to our MOSFET now. We will know once again, this is our MOSFET, the IRF-Z44N. The pins on this is going to be the gate, drain, and source. Sorry, gate, drain, and source, left to right. And so we kind of want to try and line up our gate with the output, because that's exactly where it's going to go. So I'm just going to put this line up like this, because then the second pin on the right of the TC4420 lines up with the gate. That's going to be a very simple fit for us, and we're going to choose it because it's simple and it still follows the rule of making sure that our design takes up as little space as possible. So once that's done, we can just think about where we're going to draw our power. So in terms of power, we can some options. Well, we know that we're probably going to need a power connector. So since this is this over here will be the input, and the input's going to be somewhere about here, D2. So we probably can just use a wire over here. So now we are freed up with this space over here. I'm probably going to draw I'll just use this marker to draw where I'm going to put one. So over here I'm going to have so this is just going to be ported to D2 over here, and I'm going to put a power connector over here. So it takes up these two. This will be ground, this will be, whereas you can't see anything, this will be this will be power, the V plus, which is with 5 volts. This will be ground. This will be ported via a wire, so we don't have to free this lane anymore. It will be done via a 22 multi-core wire, which I'll show you how to do it later. And then this over here is not connected. Ground will be connected to this via maybe a standard, maybe I just by solder trace, and then this ground over here can be connected through the bottom. This output will just be done like this, and there we have it. We've done all the wiring for our signal. Now we just need to think of how we're going to do our wiring for our power. So a very easy way to do it would just be simply to just put a wire below and just connect it straight onto the MOSFET. That would be a very simple thing. You might consider that. Yeah, since I don't really have many high power connectors that fit onto this board over here. Let's see. Well, let's just look. Let's just see if I shift. Well, I think I've already bent this preemptively, but maybe if I were to remove this. So what I'm going to do is I'll remove this bend over here. Just take out the MOSFET and the drivers. So if I shift the MOSFET, if we shift everything a few steps down, maybe we can fit some form of a connector that will allow us to make a more modular mount. Maybe. So we keep the same idea that we're going to put we have a little power connector, but we are going to shift everything down so we have a bit more space. Oh no. Oh dear, I think I bent this one as well. Bend it out like this. Make sure we put everything back the way it came in. Don't want to have any careless mistakes now. So I'm going to put this back. Yeah, that's the real problem with these legs. Once you mess them up, you kind of don't want to come back to the same position anymore. Alright, put this down like this. Oh my goodness. Another leg just got bent in a very dangerous way. So, goodness, and we just lost one of the legs. Hopefully that was the one that's not connected. Oh, we've just lost we've lost one of the connections for the we've lost one of the connections for the gate. Seems we have lost one of the gate, which is fine since we have two of them anyways. So yeah, I guess we're just lucky. Next time, the best way is to simply not try to push the try not to stuff it in when the connectors aren't fitting. In my case, I was a bit impatient. Now I just lost the leg. Fortunately, the leg is the lost is the second one from the right. So yeah, the second one from the right. That it happens to be the second output. In case we can just use we just use the third output. So now I will simply do the same thing as before. I'll put the MOSFET like this. I'll just remember that I have to shift the output one step to the left. I'll show you what I mean later. And now I'm just going to go ahead and take a connector which I have here. I don't know what these connectors are called, but they might be a very useful addition for our design. So I'm just going to dump it here like this. It should be quite breadboard friendly. There we go. It sits like this. We see that the lineup isn't technically correct. The gate, it sits at where the gate is supposed to be. This is the gate, this is the drain, this is the source. We can just, and I'll just remember to tie it in like this. So we're going to do that. We're going to do another curve. So it's just similar to how we're going to have to curve this output pin to the gate over here. We do the same for the other. We're going to do the same for this power connector. So first things first, I'm going to bend my components. The gate is going to bend, and of course since we've lost the first one of the gate, one of the output pins. We're just going to have to connect it to this pin over here like this. So these two have to be connected. Not a big deal. Then I'm going to bend this the drain upwards. This will be connected to this pin. In fact, I could simply just bend it to the left like this and then connect it like this. Yep, that will do. And then the source will be bent upwards straight because it just connects to the other pin like this. So we've seen we've created quite a decent connection with the MOSFET and this power connector, and then we're going to go straight for this as well. Oh dear, this thing just came out. There you go. There you are. Just put it back in here. Just like this. Okay, and then we have a similar issue with our TC4420. So we're going to bend this. Whoa, I'm falling down. Okay, we're going to bend. I'm not going to touch this pin at the moment, it's a bit fragile. I'm going to slowly bend it this way, like this, the second output pin. This should be the ground. I'm just going to bend it outwards like this so that we can solder it easily. Just do the same for the rest of the pins. So this is the other ground pin. Going to bend it this way to the left because I just want to hold the IC in place. This is the not connected, so just bend it as well. We should just leave it straight to see that it's not connected. This would be the input, and this would be the ground as well. Similar to this would be the ground too. There we go. Everything fits pretty nicely. So now we're going to find a way to solder everything on. This thing came out again. This doesn't seem to want to fit in very well. In case, yeah, when you solder it should all stick well. So alright. We're just gonna double check one last time to make sure everything is in the correct position. We bring out our schematic. We see our V out. We're going to put this to this is going to be to a connector. V out, input. Wrong. V out is here. Input is the second one, so it will be this one. V out is this. Input is this. Not connected. Ground. Output and V out. So yeah, now I'm just going to start soldering. I'm going to go for the ones which are those that fall off. We want to go for those that basically keep the entire thing. So we're just going to go for one. I'm going to go for one pin per board. So I'm going to go for the ESP8266. Well, I chose not to use pin headers to edit. It's just going to directly solder it on because firstly, because I don't think I'll be changing this design anytime soon, and also secondly because pin headers add a lot of space, but maybe I'll try pin headers and see how that works out. Okay, so I found myself a bunch of extra long pin headers. These I think were from similar WeMos modules, which I chose not to use these extra long pin headers. Well, regardless, these are just not going to be used at all in any case, so I guess I just use them and cut off the excess or use the excess as well. It's very long. Okay, this one is not from the right one. I'll go look for another one. And yeah, I found the other pin header that fits. So see that these two pin headers are likely from the exact same WeMos, not from the same board, but from the same maybe from the same type of board. So I'm just gonna put this back in over here. You see we add a lot of doing so adds a bit of height. We're just gonna double check that this won't interfere with our positioning of the board in the case. So if it does, we have to give it a miss. Oh, these are very well centered, I guess. Okay, so okay, like this, we see with a lot of height, gains a lot of height. See if we can still fit this in. So let's say the doorbell casing is like this. See if I can fit it in like this. Yeah, I think it should still be able to fit given the height, given this additional height. So yeah, I'm just gonna go and go for this because then that way it allows me to reuse my WeMos if let's say I should no longer want to use this as a doorbell. So first things first is I'll solder the important points. Just gonna mark them out. So we need to have 5 volts. So 5 volts is gonna be here. 5 volts, ground, which is next to it. What else do I need? Ground D2, which is 3 steps away from, which is the third one away from ground. So it's 1, 2, 3. This is D2. Yeah, ground. 5 volts ground. 5 volts ground. D4, D3, D2. That's spot on. And for the other side, that's all we need. I'll just solder in reset and 3.3 volts just to make sure that the other side sticks. If you wanted to, you could solder in everything, but I don't really see the point in soldering everything when you only need a few pins. So it's not just a waste of solder, but more of a waste of time that you don't really need all the pins to be soldered. So once again, definitely gonna solder in the VCC, which is 5 volts. So if you're not sure how soldering works, we're just gonna watch the video on soldering that I'm probably gonna upload soon. So I'm doing a lot of videos this time. Okay, so this board is a bit rusty in the sense that it isn't the best. It takes some time for this solder to anneal to the surface. Be careful not to inhale too much of the smoke. In fact, it's advisable to use a breathing apparatus or some form of device that may help to filter out the smoke. But for me, I kind of in a ventilated room, and also I've been don't have that yet. That was a exceptionally thick bead. I want to remove some of it, so I'm going to heat it up, work it away with my solder. Okay, seems like this will do, and then I'm just going to go for the 2 edges of this one, so it's like this, and I can see that I'm getting progressively better at this. Probably because I was not used to soldering on this board. It's the first time I'm soldering on this board in a long time. So there we go. Quite neat. You know, that last joint was not neat at all. It was a pretty cool joint. That's much better. So as you can see, we've got ourselves. Oh my goodness. Yeah. Well, see here that these 2 heights are more or less the same, but yeah, see that these 2, okay, this one a bit too, didn't press it down fully. Just gonna do this. That's why you don't solder too many, because if you solder all of them at once, you might not be able to change anything once you've pushed it in. But now in this case, I'll be able to change it quite a bit. So, alright, so once again, we're gonna look at our, since we have 5 volts, so we want it to, well, we can see what we can do with this. I don't think I can, no, I'm just going to cut away these pins because they're not, well, it must move in this direction, and currently at the moment, it's not really helping me. Maybe for 5 volts, I can try to, since the 5 volts is here, yeah, it won't help me much in the sense that I won't be able to use this folding of this pin to help me get to anywhere, since the fiber is up here. Or unless the connector, or maybe I'll check with my multimeter to see if the 5 pins are connected or not. If they are, then I could kind of use so I'm going to turn my multimeter over here. Check that if it's connected. If it is, it might simplify my life a bit. Oh dear. Okay, let's check if these two pins are connected. Yes, they are. So, okay, so I can use the 5V, this 5V pin. I'm just gonna desolder it a bit, just enough for me to bend it. This is kind of dicey because the pin is gonna be heated up quite hot. Oh, it's just gonna flick. Okay, yeah, I'm just gonna. This is really not good practice, but this is not the best practice, but meh. You should you should bend the pin before you do the solder, but in this case I was a bit dumb and I forgot to do so. In any case, I'll bend it, cool down, and we can finish the bend like this. So now I bent it down like this. Yep, there we go. Okay, so now this is the 5V and ground, and we're going to need to connect it all the way here. So honestly what we do is we just basically create a line of solder from this 5V over here to the ground, to the 5V plane. So we're just going to add the bead of solder like this to one of them and then connect it to here. Like this. I'm just gonna keep adding these beads on like this. This technically isn't a very good way to do things because you might end up wasting quite a bit of solder, since the beads are not going to sit very flat, in the sense that they're going to want to come like little balls, and then it's gonna lead to a bit of waste of solder because you don't have the flattest of connections. It becomes a bit like a small little bead of solder, but unless you want to use a wire in that sense, then that would solve your problems. But just show this once. Maybe for the ground plane I will use a wire. See here that there's a very thick bead. The bead only gets thicker. In fact, I turn this bead on its side and try to slide it down to see the bead just ends up on the table. Not a very good strategy, in fact. So what I'm going to do is I'll just use the bead to tin all the surfaces. Well, actually not. I'll actually not use this method. It's not a very good way to do things. What we could do is we could use these little resistors. We have this little thin little wires, or we could actually just take one of our wires from our single strand, single core, measure an approximate length of this solder joint over here like this, and just cut it and then remove the case, remove the plastic, remove the wire casing from it like this. Once we do that, we get ourselves this long thin piece of wire, which we can then use as to just connect we just use to connect the piece, the joint that we want. So be a lot easier. Probably be a lot easier since we don't need to do it. We don't need to connect every single point. We just need to connect the start and the end, and then the wire will transmit the current. So let's bring this back up. Got this over here like this, and I'm gonna put this up here like this. So there we go. So we've got ourselves the first connection between the power and the 5 volt of the WeMos and the power of the TC4420. At this stage, we're just going to repeat the process for ground as well. Snip off any excess bits. Like this. And do the same thing for the ground. In this case, ground is all the way at the end, so I think of a way to bring this all the way to the end. So let's see. I'm probably gonna cut this leg off like here, like this, so I get a bit more room. In fact, while I'm at it, I might as well just solder on the output to solder the output to the gate like this. Yep, so I'm going to get into the output, and now I'm going to take once again, in this case, let's try using the other method, which is to use these not single core but these multi-core wires, and we're just going to just forward what I call routing the wires. So first thing we do is we take we want to measure the length, so we strip it first. We just measure the rough length of this between and the place we want to go to, so about here. Then we cut it at the length, and we strip the other side as well. And then this will give us a small bit of wire that we can use to basically push. We can basically use this wire to forward the current. So I'm going to go ahead and tin both sides over here with my soldering iron. So yeah, I'm just going to do tinning using my soldering iron. side, the other, like this. And then I'm just going to go back over here and I'm just going to put it onto the point where I want it to start, which is going to be around here. So just going to heat up a bit, get it. First add a bit of solder onto the surface of the mount. Just going to wind back my solder. So get a bit onto the surface like this. Right, and then it stinks. And then we're going to stick this onto the point, that little pad that we made over here, like this. Now that that's done, it's stuck fast. Then we can just maneuver it and put it on our second point, which in this case will be the ground. This will be the ground pin of the TC4420. We're just going to do this, prepare our spot, and then just maneuver our wire to sit on that spot. Right here, like this. There we go. So it's very nice clean forward of the pin from the ground of the WeMos to the ground of the this TC4420. Now what's left is just going to be we need to put in our power connector thing over here. That's gonna go in like this. Next to these two, I'm just going to solder them on. The problem is it's going to keep coming out. So we're going to try to keep it on, either with tape or just by using the edge of the table. I should shift this. I'm going to keep it on the top, keeping this at the edge of our solder reel like this. I'm going to bring this over here, just gently start soldering. So and then we solder this onto the board. That should do it. And repeat this for the other side. Now that it's stuck fast, we don't have to bother to try to push it on. We can just take our time and slowly add it to the board. There we go. Pretty nice finish. Alright, so now that's done. What's left is we have to just attach on the, in this case the ground is already attached. We just need to put our power connector, which will be the ground, and we put our power connector. So my power connector, I'll be just using a simple 2-pin. I'll just be using a call a small Molex collector, which is connector, which is something like this. So we're going to take a simple 2-pin Molex collector. Just going to stick it in to act as our power connector. A very simple solution. So this is not a Molex, this is the JST. I'm not wrong. It's a Molex connector. I think some people call it JST, but I think it's got a Molex. I'm not too sure about that. Oh well, yeah. Well, this one is the one that they use for model aircraft, the balance leads. So we know that once again, the power is going to be, VC is going to be here. Put it in like this. So VCC is going to be this, and ground is going to be the one that's at the so ground is going to be here, and VC is going to be here. It's going to be pretty simple fit for us, in a sense. Okay, maybe before that, if I should first fix on the wire for our input. That's because it's going to be, I mean, we can change the position of our power controller. We can't change the position of our input. So just going to double check again. Looking over here, we see that the input is going to be the second from the top, so it's going to be this one, which means it's going to be this one over here. So we're going to put use the same technique. Maybe use orange wire this time. Going to strip a little bit of wire over here. Then we're going to measure the length we need. So it's going to be from here all the way to, say the input is going to go all the way from here to this one over here. So maybe just the length of wire this long will be enough. I'm going to cut it over here. Just going to strip the other edge. And just clean up the strafe. Oh, I just removed one strand. Oops. Should make a difference. And I'm going to go again and tin it. It's going to be the same process as before. Nothing new here. Then I'm going to just add it back onto this. So same thing as we did before with the white wire. We're just going to go over this ever so slightly and just add some solder to basically just cement its place on the board like this, and make sure that it's not connected to any other wire, any other pin. That would be quite disastrous. And then we just go ahead and add this orange wire onto it like this. In this case, I might want to move this away for a bit, just so we can, maybe I'll just put it underneath like this, so it can sit right on top of this very neatly. Alright, that sits nice. Just bring this around and then we just put it onto this pin over here, which is our D4 pin. Now we've gotten we've basically done almost all of our wiring. What's left is just the power connector. So once again, we double check. This just got wired on. This is the input, and yeah. So now we just, our power connector will just be sitting somewhere here. Sit somewhere like this, and yeah, let's just add it on. So once again, just how we wired our other power connector, we're just going to put it on the edge of this, or like this, and then just solder it on like this. Make sure to just barely add just enough solder. You don't need too much. So this is good. And this is also good. Nice, very clean edge of this power connector. And now we know that for this, we know that this is going to be the power in, so we can just go ahead and add like this. Right here, we're just gonna connect this joint like this. Like this over here. And then just add some solder over here to complete the joint. Making sure that we don't connect the pins that we don't want to touch. That would be quite disastrous. So we have just a simple solder joint like this. It's very clean. And then for our negative side, we're just going to go ahead and connect this all the way and bring it up to here. So now that we have it connected, we don't even need this anymore. Once again, this is just maybe three boxes, so I'll just use the solder method again. So connecting this to here, and just connecting the rest like this, and then like this. There we go. Pretty clean. And I'm just going to use our multimeter to check that none of them are shorted. So let's again take our leads. Check that these two are not shorted. These are very close to each other. They are not. Check that these two are not shorted. Check that these two are not shorted. And we also can check that our connections are true. So from here to here. This is good. Check that these two are not shorted. And actually we can do this as well on the top. So we just check that both our power pins are connected to each other. The ground and power are not shorted. But ground and ground are shorted together. And no other two pins are shorted. So for instance, if this is shorted, this should not be connected. This also should not be connected. This might. But this should be connected. So this and this probably are connected. So the gate and just check that the gate and these are connected. So everything's fine. Now we can proceed to cut out the board with a pair of tin snips. Just want to remove unnecessary material. Then we can fit it in. So I'm just going to use my tin snips and just cut out the board. You see that when we cut, the outside kind of curls up. That's how this tin snips actually work. Okay, nice. You've cut out a pretty decent snip of the board. This is the board we need with all the parts that we have here. So we can see that this is going to fit quite nicely into this region, and in fact we're just going to use our side cutters and cut out all the little pins at the bottom of this because we just don't need them anymore. So I'm going to angle it down and just cut them out. In the future, if we want to use more, we can just solder them down, but at this point I don't think we will need more pins. At least we don't need to bend these pins because there's really not much space at the center of the board anymore. In any case, yeah, it's just going to inhibit our mounting of this, and it's not going to add much benefit for now. So I'm just going to remove them. As you can see now, we can fit our board very nicely into this small gap over here. And once again, we're just going to try out this board, but not with this. We're going to try this board out. Going to use Okay, but we're going to make sure everything to put everything in this time. So once again, going to remove the wires to the remove the wires of this. Just like this, and then I'm going to find a way to solder this back on this piece over here. So we're going to have to solder it out. Alright, so I wired everything up and this is the end product. Pretty neat. See, I've added the male JST, or should I call Molex connector, and I've just drilled some holes to screw in the power supply, the SMPS onto here, and now pretty neat.